Welcome to Praveen Patil College of Diploma Engineering and Technology. Myself Raj Khiware, working as a lecturer in Mechanical Department. We are looking on subject Theory of Machine. We have seen chapter number 2, that is Velocity and Acceleration in Mechanism. So in this we have solved the problems on the crank of a sliding crank mechanism. Now we will be looking at the analytical method for determining velocity and acceleration of slider crank mechanism. So here we have to consider the motion of a crank and a connecting rod of a reciprocating steam engine, as we are able to see from the figure. So here let OC be the crank and PC be the connecting rod. So let the crank rotates with angular velocity of omega, that is in radian per second, and the crank turns through an angle theta from the inner dead center, that is IDC. Let x be the displacement of a reciprocating body P from IDC after a time t seconds, during which the crank has turned through an angle theta. The motion of the crank and the connecting rod of the reciprocating steam engine. So this is the length of the connecting rod, this is the radius of the crank which is at a pinch circle, this is the angle of the incline of connecting rod to the linear stroke PO, whereas n is nothing but the ratio of connecting rod to the radius of the crank. So for analytical method we have certain formulas, that is the first one is for displacement of a piston, velocity of the piston, that is omega r in bracket sine theta plus sine 2 theta divided by 2n. N is nothing but the ratio. Acceleration of the piston is given by omega square r in bracket cos theta plus cos 2 theta divided by n. This is the formula for angular velocity and angular acceleration. So by utilizing this we can solve the problem, we can determine velocity and acceleration without going for graphical representation. So here is the problem which we have to find out the velocity and angular velocity and angular displacement. So I will just read out the problem. In a sliding crank mechanism, the length of the crank and a connecting rod are 150 mm and 600 mm respectively. The crank position is 60 degree from inner dead center. The crankshaft speeds in RPM 450 in a clockwise using analytical method. So here in the question itself it has been said we have to use analytical method. So using analytical method we have to find first is velocity and acceleration of the slider, second is to angular velocity and angular acceleration of the connecting rod. So first of all we will be writing the given data, that is radius is provided, length is provided, theta is provided, rpm is provided. So omega value we will calculate, that is pi n divided by 60, 2 pi n divided by 60, and then we will be going to calculate the first one, that is velocity and acceleration of slider. So as we have seen the formula which is present over here, velocity of slider is nothing but velocity of piston. So this is the formula which we are going to use in this problem. So that is omega r sine theta plus sine 2 theta divided by 2n. So n values is nothing but the ratio which we will be obtaining. So when we substitute it, we will get the velocity of slider. So same way we will get the acceleration by utilizing the formula, and hence we can solve this very easily. Now the second is to calculate angular velocity and angular acceleration of a connecting rod. So here also we will utilizing the same formula which we have seen over here, that is this one. This is the formula for angular velocity of connecting rod and angular acceleration of connecting rod. So we will be utilizing these two formulas over here. So this is the formula which they have utilized, and we will substitute the values. So omega value which we obtained, and cos theta was given as 60, and values as the ratios, that is 4, and we will get the angular velocity as well as angular acceleration of the connecting rod. So this is how we can solve the problems by using analytical method. No need to go for drawing diagram, that is for graphical method. By utilizing the formula and directly we can substitute and we will get the values. Now we will be looking at the next method, that is Kelvin's construction for velocity diagram. So for velocity diagram, what we have to do is, in order to get a velocity diagram, this is the original image. Okay, so what we have to do is we have to extend the point of OP till this much, and from here O we have to extend a point to upward, so that we will get a triangle like this, and this triangle which we get where after extension of point, that represent velocity diagram. So here are the certain steps which we have followed, and we got the velocity diagram. So apart from this, how we can construct for acceleration diagram of a slider crank mechanism. So here are the certain steps which we have to follow. So first of all, we will extend the line QR. First of all, we will extend the line QR, which is located over here, that is over here, QR. Now also we have to draw OR, that is perpendicular line from O. So we will get a point, that is R point, as a intersect point. So this is the R point which we have obtained as a intersect point, and then we have to draw a circle where we have to take a radius from P to R. So that is, we have to take a radius from this P point to this R point, and we will draw this smaller circle. So once we draw this, we have to take another circle. So the another circle will be drawn from the point, that is from Q to R. We will take it as a diameter. Okay, so we will be getting the circles. So this is the arc which has been drawn and through which the circle is been constructed. So then the last step is we have to join W and S, that is the point of intersection of this two circle, and we have to extend it till downward, so that on this line we will get Z point, and on PQ we will get T point, that is this point. So what we conclude over here is, here in this we have getting a quadrilateral, that is this one. We can see the quadrilateral which is present over here in shaded form. Okay, so over here this OP represent for the centrifugal component of the acceleration, TP represent for the acceleration of connecting rod, QR is nothing but acceleration of PQ, ZT represent the tangential component of acceleration, whereas the last, that is OZ, represent acceleration of a slider. So this is all about acceleration diagram by using Kelvin's construction of for acceleration diagram, and this was the diagram for velocity by using Kelvin's construction. So that's all for today's. We will stop over here.